Topic 4, Lesson 9, Manufacturing Processes. What you're seeing up here on the top right, we'll see again in just a second, but this is plastic injection molding. And the plastic is fed down in through this hopper. It's melted in here, especially as it's getting pushed along, because this is like a big corkscrew. Pushed along, it's getting compressed and heated. Melts to the point where it gets in here, it fills this cavity, and then plunged through here to fill the mold. Different manufacturing techniques have been developed to innovate existing products and create new products. For example, 3D printed houses. It's a real thing. Design for manufacture. Designing products in such a way that they are easy to manufacture. It's also abbreviated as DFM. It exists in almost all engineering disciplines. The focus is on designing of a product's components and designing for the quality control and assurance. Manufacturing processes. There are 4 classifications of manufacturing processes that are common across all manufacturing. We have additive techniques, which you think of as 3D printing, but basically you're starting with nothing and you're adding material until you get your finished product. We have wasting or subtractive techniques, where you're starting with a solid block or cylinder and you're cutting away at it, producing waste until you have your finished product. We have shaping techniques, where you're taking a material, oftentimes you're heating it up, and then you're shaping it into the form you want. And we have joining techniques. In this case, they're showing welding, where you're taking 2 different materials, heated, well, they don't have to be different materials, but 2 different pieces. In this case, heating it up, possibly adding a third material, second material or third material to bond them together. Additive techniques. Examples: paper-based rapid prototyping, which I guess is this, or it can be something like this if this is a paper they're feeding through. Actually, this would be your second one, laminated object manufacturing, right here. And stereolithography, right here. Now remember, stereolithography uses a plastic polymer, a plastic liquid polymer, and when you zap it with a laser, it solidifies, and this platform here lowers, and as it's lowering, it's building it layer by layer until you have your finished product. When done, it'll just push the product out of the bath. These are examples. Wasting and subtractive techniques. You can do cutting, like for example with scissors or shears. You can do machining, like with a CNC mill. You can do turning, like in a CNC lathe, where this middle part is on a cylinder and it's spinning, and this blade is getting pushed onto the outside and it's cutting away. Or you can do abrading. Think of abrasion, where you are removing material by rubbing something against it. In this case, some kind of like a sandpaper to get this wing exactly how they want it. Shaping techniques. You have molding, thermoforming, which, this would be thermoforming right here. Molding I don't have on here because you've already seen examples. Laminating. Casting. When you hear casting, think liquid metals. When you hear molding, think plastics. Knitting, which would be this top right one. And weaving, which would be right here. Oh, sorry, your molding is this, obviously. That's the one we started with. That's your plastic injection molding. Joining techniques. You can have permanent joining or temporary joining. IB would like you to know that the more environmentally friendly would be temporary, because then when a product is done, you can pull it apart and more easily recycle it. You can have fastening with nuts and bolts. You can have adhering with different types of glues, adhesions. And you can have fusing, things like welding. Selecting appropriate manufacturing technique is based on several different characteristics of your materials. What is the form that you're going after? What is the melting or softening point of your material? What is the cost? What are the capabilities that you have access to? What is your scale of production? Are you doing a one-off product, or are you mass producing this? What are the desired properties of your finished product? International-mindedness, as if we haven't said this before, but more expensive modern processes tend to take place in technologically advanced regions and countries. So I put an image on here. This is a chart of the 50 least developed countries. Aim 8. Advancements in 3D printing have resulted in the ability to have a 3D printer at home, which some of you probably do. Consumers can download plans for the products from the internet and print these products themselves. For example, most of you are familiar with Thingiverse. It is like a public library of 3D printable stuff.